Welcome, class. This is a video on improper integration, but first, I want to talk about infinity. So what is infinity? What is 1 over infinity? Infinity is a number that just keeps getting bigger and bigger forever, right? But so infinity just onto a big number or negative infinity. What is 1 over infinity? Well, technically, the way to look at this is you're looking at the limit of 1 over, let's say, n as n approaches. That's really what we're doing. And as it gets bigger and bigger, we can say it's 1 over infinity. This number is getting smaller and smaller. We can actually just say it's equal to 0 because the bottom's so big that we can just say it's 0. That's how it works out mathematically. Infinity has other little weird properties too. No, what's infinity plus a number? If I go infinity plus 5, it's still going to be infinity. I said same thing if I subtracted a number, it's still infinity. If I multiply times 3, it's going to be 3 times infinity is still infinity. Same thing if you divide. If I multiply by a negative number, negative 1 times infinity, we'll have negative infinity. So those rules still apply, the negative rules. But you add, you multiply, it doesn't matter. Square root. If I square root infinity, it's still getting bigger forever. It's just rooted it. It's still going to be infinity. If I go e to an infinity power, this is still growing. We can call this an infinity. It's just infinity written at different ways. These are all going up to infinity. Now I'll say, does everything go to infinity? Well, no. We have cases like 1 over infinity, which went to 0. What if I said like 1 to the infinity power? Well, 1 times a bunch of 1s is going to be just 1, right? I think 0 to the infinity is still 0 too. Some weird rules with this. I'd say this. Other x rules. E to the negative infinity power. That would be negative infinity, right? No, that's the same thing. Follow your laws of exponents, right? To the infinity, which would be 1 over infinity, which is going to be 0. So we follow those other rules as no, don't drop. Heck, no. Last time it fell, it paused the video. Didn't realize it. Moving on. So sometimes it's infinity, sometimes it's not. I'm sure I can pull up some other examples here. What I want to say about all these things is that, actually, let's go from the top, is some of these are what we're going to write converge. Some of these, when we go to infinity, we're going to say these diverge. And I'm going to write that in blue up here. We're going to say these examples diverge. These are diverging. You diverge when you go to infinity or you go to negative infinity. This is not going to diverge to a number. And the opposite of that, when you actually go to a number, is going to be converge. When you go to another number, whether it's 0, whether it's 1, it doesn't matter what the number is. But if it's a number like pi, even irrational numbers could be converged to those. So diverge is when it involves infinities. Converge is when it has a number. This is going to be important for this lesson. So hopefully we're ready for improper integration. Hope you can read this. Find out. So improper integrals are when we're using infinity or infinity concepts like this, right? These are integrations. So here's when one or both limits are infinite. So if I'm integrating 1 over x from 1 to infinity, or if I'm integrating from negative infinity to positive infinity of something, those would be improper integrals. So we're going to have to keep those concepts in mind. Another case, there might not be infinity signs, but it's these infinite discontinuities. This is when you're dividing by 0. But it's like when they would create an asymptote. So not like holes or jumps, but there's an asymptote. You're dividing by 0 in here. So for example, and it's either in between the limits or at the limit. So if you're integrating 1 over the square root of x minus 1 from 1 to 5, plugged in a 1 for x, that won't work. So, and that's the left side, the lower limit right there. And so that's why it's infinite continuity by improper integral. This one right here goes negative 2 to positive 2 over 1 over x plus 1 squared. And you're like, well, negative 2 and positive 2, those are okay to plug in. But wait, if you plugged in negative 1, which is in between those, you would be dividing by 0. So at negative 1, we have a discontinuity there. And that means we have to do a few different things to integrate it. All right. So these are problems. That makes these discontinuities. Other things about integrals these are either going to evaluate to a number, converge to a number, or they will diverge. So going back to that last concept, converge or diverge. If they divide, it diverges when you have an answer that's infinity or negative infinity. There's part of the answer comes out to an infinity, we say it diverges. So we don't say, oh, the area under the curve is infinite. We just say it diverges, right? Negative infinity, no. But if it's 1 over infinity, you can write that as 0 and say, yeah, it converges. So just because it's like, so you gotta understand that infinity math still for convergence. All right. So that's what we're looking at today. Now we'll have weird concepts. What if I said the limit as n approaches infinity of n over e to this is, so you say, oh, it's infinity over e to the infinity. Does this converge or diverge? I'd be like, I don't remember. Maybe you do. We'll come back to that problem though. But let's talk about an example. So what if I had the equation 1 over x squared? That graph looks something like this. Looks like there's an asymptote on the x-axis, on the y-axis, and it's just like two curves. They go up to those asymptotes, right? And what if I said I wanted to integrate from 1 to infinity of this? Well, that's going to be a finite amount of space, right? Well, that's infinite amount of space. It keeps going to the left forever. There'll be a little bit above, so it'll always be getting a little bit bigger, right? So you think, oh, maybe it's infinity. Well, let's find out. So, okay, so here, pay attention to this. So you have to do some limit notation here technically to be technically correct. So what you're supposed to do, since this is an infinite here, I don't want to put infinity on these limits. I'll actually rewrite this as limit as I'm going to say b goes to infinity. Why did I choose b? Because it's on the top. Of 1 to b 1 over x. Now technically as you go to infinity from, you have to say from the left. I was going to say from the left, and I did this in my first take, but I mean, you're not going to infinity from the right. I mean, whoa, my mind flew right there. Let's just say infinity. I think you'll be okay. You technically have to do this, all right? If you had a free response on an AP test, they do. Show you how I really do. So, okay, let's do this. Antiderivative of 1 over x squared right here. That's going to be negative 1 over x. And I'm going to go 1 to right here, same right here. So plugging this in, it's going to be negative 1 over b minus 1 over 1 minus negative 1 over 1, excuse me. And then it's going to be the limit as b goes to infinity still. And then what do we have here? Well, negative 1 over b will be plus 1 right here. If we're dealing with this limit, the same thing as that's like negative 1 over infinity to 0. So the 0 plus 1, so my answer is, 0 plus 1, you can't see it. Oh well, I can. Answer is 1. So it did converge. We can say that answer is going to be 1 as it converges. All right. I'd say, oh, well, do they all converge? Like, no, they don't. Let me show you an example where they don't converge. What if instead of 1 over x squared, we go with 1 over x? Same thing, 1 to infinity. The graph of that, like, then basically. And so it's going to look similar. But say, oh, it's just the same thing, right? The graph basically looks the same, but won't this converge to the same number? And why would the last one? Well, let's see what happens. So, okay. That limit thing you're technically supposed to do, but I'm just going to do without it because I hate it. I mean, I don't know. You have to do it for the AP test. I think it's implied, but you'll see later. Okay, antiderivative of 1 over x is going to be natural log of x from 1 to infinity. Yeah. So that's going to be natural log of infinity minus natural log of 1, right? Get that? You're like, okay, well, natural log of 1 is 0 if you go back to your log rule. log of infinity is just infinity. We talked about that before. So if I have infinity minus 0, my answer is infinity. We actually say diverges. Like we said before with the rules, if you get a case where your answer has infinity, diverge. In that case, have it. So there. Infinity minus 0. If it was infinity minus 1, it wouldn't matter. If it or limit of 1, who cares? Diverges, we're done. All right. Okay, let's do some other examples here. Because, hey, maybe you want to see some more and some other weird cases. So I want to let's go through these. So let's do the case that we did in our example of 1 to 5 of 1 over square root of x minus 1 dx. All right. This is one of those we just had over here. And okay, we know that the bottom one is the limits one. So technically, we'd have to do this as, let's say, since it's the bottom, I'm going to say a goes to 1. Probably should say plus, though. So the a to 5 over square root of x minus 1 dx. Okay, this was an AP test and free response. I'm writing all that out. All right, so antiderivative of 1 over x squared. This is kind of a u substitution thing. Oh, geez. What is that? I'm going to work over here on the side. That's like the same thing as over square. It is like u to negative 1/2. Antiderivative of u to negative 1/2 would be u to the positive 1/2 times reciprocal 2 over 1, which is the same thing as 2. So in this case, with the substitutions, this is going to be 2 square root of x minus 1 from a5. Okay? And then I'm going to plug those in. It's going to be 2 square root of 5 minus 1, so 4, minus 2 square root of a minus 1. Okay, well, this is going to be times 2, 4, minus 2 times, remember this limit thing here? I didn't forget about this. It's going to be 2 times square root of infinity minus 1. That's just 2. Infinity. Diverge. This is a case where it would diverge because of the infinities. Yep. Oh, wait. I'm an idiot. Did this wrong. We aren't plugging in infinity. Oh, geez. You guys should have told me. Wish you were here live. I won't edit that. I made a mistake too. You know what? I deserve this. Anyways. So I gotta plug in 1. Duh. So this will be 4 minus 2 times square root of 1 minus 1. That's just 0. End up being 4 minus 0 or just 4. That actually comes out to a number. You know, the limits, the left-hand, right-hand limits didn't really matter in this case. Sometimes it might in a problem. Technically, you have to do it. All right. Do another problem. I'm going to erase that. I'm going to do that other problem from these examples, or one of the other ones. And let's say I did, I want to do the one that's in the middle. X plus 1 squared. So you're like, oh, it's in the middle because it's at negative 1. What do we do? Technically, you have to split this up. You have to do this as negative 2 to negative 1. And then plus integral from negative 1 to positive 2 over the same. Because you got to split it up at here because of the way that at that asymptote there's different behavior than just integrating across the board. Okay, technically I gotta do my limit thing, right? I'm just not doing the limit thing this time. You know what I mean. Antiderivative of 1 over x plus 1 squared. Well, the antiderivative of 1 over x squared we found out was negative 1 over x. So and it's not going to really matter with the u subs in this case. So it'd actually be negative 1 for x plus 1 Let's say from -2 to -1. And then over here, it's going to be the same thing. Plus -1 over x plus 1 from -1 to +2. Now watch what happens with the math of that negative. You think, oh, maybe they'll cancel out, right? So we're going to plug the -1 in first. Now, okay. Done these. Because you have to think about this. If I would just plug the -1 and have a 0 down here. Oh, wait, maybe it doesn't matter. So I'd have a b plus 1 minus, oh, no, it is going to matter. -1 over -2 plus 1. Let's just do this math first. If you plugged in an infinity over here, you're going from infinity from, oh, you're not going to infinity, you're going to -1. But you're going to -1 from the left of it, okay? So what is this going to be on the bottom? We're plugging a number that's a little bit less than -1, a little bit more negative-y. We're going to get like positive infinity. Because if you do this limit right here, the limit b approaches -1 from the left, and you see if you want to see what that graph looks like. -1 is going to be right here. Oh, the asymptote for this case, like there, put right here. -1 from the left is going to be going up to infinity. Okay, so if it's going up to infinity, and even on the right, they're both going up to infinity. So that's good to look at as we do this problem. So I could say, hey, on the bottom, I have infinity plus 1. What's -1 over infinity plus 1? Just 1 over infinity, which is just 0. All right. In this case right here, I have -1 over -1, and then a minus out here. I think that's -1 if I'm doing that math right. All right. Drop down that plus. Same thing over here. Let's do this math. So it'll be -2, -1 over 2 plus 1 minus -1 over, let's not call this -1, we'll call this b, over x plus b. Now we just did before, it's going to go up to infinity when you want a -1 from either side. It doesn't matter in this case. So I have -1 over 3, have plus 1 over infinity. So that's 0. My final answer. Yep. My final answer. -1 plus -1/3 plus 0. It's going to be -4/3. So there. I had to split that one up. That's probably one of the most work you have to do these. Sometimes you might have to do it. I've seen it on the AP test. It's worth showing to you guys. All right. That's it. Stop in here.